In the process of our discussion over the last, well, actually, the entire unit we've discussed so far, we've done a lot as it relates to protons and electrons. We've covered neutrons as well. But we've talked about changes in protons, that making it a different element. We've talked about changes in electrons, that making it an ion, either a cation, which would be a positively charged ion, which means it gave away some of the negatives, therefore being positively charged, or acquiring electrons, therefore being negatively charged, because now there's more negatives than positives. Now we're going to put some of those things, concepts together as we discuss about the differences between acids and bases, and also understanding the differences between those two things. For example, what makes something a stronger acid than another, and which one makes something a stronger base than another. And also, hopefully we want to tie that together as we go along to, well, in our body, we're constantly becoming acidic or basic, and not quite to the degree that people want to market products to you to make you, okay, you're going to be, because you're so acidic, then this is going to happen to you, or because you're so basic, well, this is going to happen to you. We'll understand that, okay, yeah, that's not true, and we'll describe why. Now, from a healthcare standpoint, do we have patients that becomes true when they're critically ill? Absolutely, and we'll kind of clarify those situations as well. So one of the first things we want to do is we want to define, well, what's an acid? And as you take a chemistry course, you're going to get a lot of different definitions of this, and we're going to try and make it as simple as possible, and also as simple as possible when we talk about bases. But an acid is a substance that, when dissolved in water, forms one or more hydrogen ions and then one or more corresponding anions. Now, it sounds a little bit complex, but if we look at that and notice in the graphic where here we're demonstrating a very common acid we refer to, hydrochloric acid. And when placed in water, it will dissociate, because what's happening here is we have an element from the left side of the periodic table and an element from the right side of the periodic table. This one being willing to donate its electron, this one gladly be willing to receive its electron. Therefore, this becomes, the hydrogen becomes the cation and the chloride becomes the anion. And so we end up with two ions that are attracted to each other. Oh, we know what that is. That's an ionic bond. And we know that when placed in water, these ionic bonds can dissociate. And therefore, the hydrogen ion would rather be by some of the water molecules, and the chloride ion would rather be by some of the water molecules. So we end up with an ion that then dissociates into its corresponding cation and anion. And it just so happens that the cation is a hydrogen ion. Now, one of the things I want to clarify as we look at these acids, because what we're going to do with these acids is we're going to measure the concentration of those hydrogen ions. And we're going to put them on a scale where we indicate how concentrated they are. And that scale, of course, is our pH scale. We're going to refer to that a little bit more here as we go along. Okay, so if that's the definition of an acid, well, the definition of a base is a substance when dissolved in water forms one or more hydroxide ions and a corresponding now cation. We don't really care what the cation is. To be a base, it releases a given number of hydroxide ions. Same was true up here with the acid. We don't care, okay, what the anion was. We only know to be an acid that it's releasing one or more, okay, or a concentration of hydrogen ions, and that's what we want to describe. So acid, always look for the hydrogen ion. Base, always look for the hydroxide ion. We really don't care what the other is. Now, what if we have a situation where something dissociates in water? Okay, let's look at table salt. Table salt, NaCl, dissociates. It's an ionic bond, element from the left side of the periodic table, element from the right side of the periodic table. Sodium loves to give that electron. Chloride loves to receive that electron. We have a positively charged atom, the cation. We have the negatively charged atom, the anion. They have this natural attraction to each other because one's positive and one's negative. But notice in that situation, if we put NaCl in water, or in this case, we put potassium chloride in water. As it goes into water, it dissociates into its ions, one being a cation, one being an anion. But notice, neither of which is a hydrogen ion, and neither of which is a hydroxide ion. So it can't be an acid because it's not a hydrogen ion, and it can't be a base because it's not a hydroxide ion. So that is a salt. So if a substance, when it dissociates in water, releases one or more hydrogen ions, it's an acid. Releases one or more hydroxide ions, it's a base. If it If it dissociates into ions, but neither of which is those two, then it's a salt. That's the definition you need to understand as far as the context of our discussion. So here's all three of those together. Here's our acid, Y, hydrogen ion. Here's our base, Y, hydroxide ion. Here's our salt, why? Because it doesn't have either one of these two. Now, as we describe when these become strong acids versus weak acids, strong bases versus weak bases, we describe them in the relationship of, well, how many of those ions does it release? So, for example, if we look at, I'm going to draw this, if we look at the situation with like hydrochloric acid, HCl, that when placed in water, it dissociates into its ions, given number of hydrogen ions, given number of chloride ions. Then if we have a situation, this is one we're going to talk about, which is carbonic acid. If we place this in water, we do get these. Therefore, what does it make it? An acid, which would leave, what would be left over if we released it, isn't that horrible? If we released, trying to put two words together there, okay, if we released hydrogen ions, well, what does that leave up here? Well, if it releases a cation, it has to have a corresponding, and it does, anion. That's our bicarbonate ion. You should recognize that. But the difference in these two molecules is the fact that when they dissociate in water, this one nearly completely dissociates into its ions. This one does not. And so what it has in the solution is it still has undissociated carbonic acid molecules. So really, now this is something you kind of have to memorize and look up, but if I place, let's say I took a handful and there happened to be 100 of these that I placed in water, what would happen is that from that, okay, I would get about 100 of these and 100 of these because they almost completely dissociate. So whatever I put in here, I'm getting them here. So I'm going to get a very high number of these. So it becomes very acidic. And so we refer to it as a strong acid. Versus in this scenario, we get some of these, but some did not dissociate. And somewhere around, if I put 100 of these in solution, I only get 5 of those. Well, when I'm measuring acidity, I'm measuring how many of these hydrogen ions do I have? What's its concentration? And so if I put 100 and I get 100 out, that gives me a lot of hydrogen ions. Therefore, that makes that very acidic. If I place this in water, that still gives me hydrogen ions, so that still is acidic. But, yeah, notice I don't get very many of them. So the definition for a strong acid versus a weak acid is a strong acid completely dissociates into its ions. A weak acid, okay, does not. Okay, incompletely dissociates, I guess would be the term. Now, at the bottom of your slide, it gives a great example of this. Great example being a molecule called citric acid. So here's our molecular structure of citric acid. And notice that it's a weak acid because sometimes, but not very common, notice rare, does it release a hydrogen ion. Sometimes it can but even rarer still, but it can release 2. Sometimes, even rarer still, it can release 3. So by being able to release a hydrogen ion, what does that make it? That makes it an acid. But it doesn't like to do it very much, and it doesn't release very many, so that would make it a weak acid for that reason. Now, we can apply the same rules to our bases, that if it completely dissociates into its ions, hydroxide being one, then it's a strong base. If it incompletely, in other words, it doesn't release very many of them, it would be a weak base.